Hello everybody, we are here at CyRAM company in France in our plasma laboratory where we're going to demonstrate the operation of the downstream plasma source with the automatic 4-step tuner and with 3 kilowatt generator at atmospheric pressure in air. So my name is Konstantin and I'm here with Nicolas. I'm gonna show you Nicolas. Here you go. And here's the system. So let's start from the beginning. Here you have on the bottom you have the generator, 3 kilowatt. This part is power supply. Then it goes to the head, isolator. Then this is the automatic 4-step tuner, the downstream plasma source with a tube of 30 millimeter outer diameter. Here's the gas injection. This is a vortex gas injector, which allows you to operate at atmospheric pressure for a long time at high powers. And this one is the sliding short circuit, and here this small tool that we use to ignite the plasma. We're gonna show you later. Okay, I will talk to you a little bit about the cabling. This one is the last unit I didn't tell you about. It's the human machine interface, so it's called CBA. It's in rack form, can be also in tabletop. It allows you to control remotely the generator and the 4-step tuner, and it also powers the 4-step tuner. Let's see the connection for water and for power of everything. So here you have the generator. This one is American standard model, 3-phase 208 volt. Here you have the water connection, 10 millimeter inner diameter tubes, quick connectors, so we provide those. And here you have remote control gateway board, and these cables, this one goes to the microwave head for power. High voltage goes here also to the microwave head, and this is the canopy control. It goes from the CBA control unit to the generator, and from the generator it goes also here. So it's in series, canopy control is in series, so it goes first generator and then 4-step tuner. And the last thing, well, there is a safety interlock, so we short circuit it. And the last thing is the BNC connector. It's here, and it also goes to the isolator here, which is on the magnetron head. This is for reflected power measurement, and here you see, as I have shown you already, the high voltage and the power from magnetron head. The water is going also in series, first power supply, and then here it goes to magnetron head, and then it goes to the isolator here and comes back. Okay, so that's it. For water cooling of the source, here you have 6 millimeter outer diameter of connectors for the body of the source, and we also water cool the vacuum connector here with the vortex injection. And you have air cooling of the chimneys of the plasma source. This is more for the quartz tube to evacuate the heat, so it's here and here. You can also add the air cooling here closer to the chimney's output, but these ones are more critical, so it's on the bottom of each chimney. And here you have the gas injection, so we use compressed air, and here is our flow meter, so it allows you to do the fluxes from how much? From 1 liter to 100 or even more? 700. But well, with our compressed air here we can go up to maybe 150, not more. Okay, let's operate it. So as I said, this one 3-phase 208 volt, so we are here in France, so we have to use a transformer here from 3-phase 400 volt. Okay, let's start. So what we're gonna do is that we're gonna put the gas flux on. We're gonna start with a microwave power of 2 kilowatt here, and the sliding short circuit here, it's in middle position, You see here, it's in the middle. And the 4-stop tuner is on. So it's going to adapt, and we see if the adaptation is good enough. Nikolai is putting the gas flux. Let's do 70 liters per minute, something like this. You start? Okay, good. So now I'm putting the microwave on. Off. Here we go. So we have 2 kilowatt. We have reflected power because the plasma is not on. Okay, so Nikolai is going to inject the rod with a metal tip inside the source up, and it's going to ignite. Here we go. Okay, so the plasma is ignited, and we see that the reflected power is going down because the tuner, 4-stop tuner here, is adapting automatically. And the plasma is nice and centered thanks to the vortex gas injector that enters the gas from both sides, and it creates kind of a swirl. So the effect you can see on the top, it's open here, so I'm going to show you through the glass of the protection goggles. You see the plasma is well centered inside this circle in the middle, and it doesn't touch the tube walls. So you can see here also that it's well centered with respect to the walls of the quartz tube, and it allows you not to burn your quartz tube because the plasma is not in contact with the inner wall of this tube. Okay, so let's see at our reflective power. Should be very small. So it's 10 or 20 watts. This is really not so much. So what we're gonna do is we're gonna increase the microwave power here. Set point. We're gonna put 3 kilowatts. Off. Enter. So you see it has adapted already quite good. And you see the plasma is more intense. Okay. So I think what we're gonna do is we are going to change the gas flux. So here we have 70 liters per minute, which is quite a lot. So we're gonna spare some compressed air and put 30 or 20, 120 or 20, 120. Okay, so we increase to 120. And you see the plasma is, wow, the column has become longer. Okay, how about we go to 30 or 20? Complete. Well, we're going to decrease the gas flux to 30 liters. You see the difference? Up. Wow. So the thickness of the column is much more, and the ionization is quite efficient. You see the plasma is much brighter, and also the column is longer. So that's how much the variation of gas flux can change your plasma. Yeah. Okay, and we see still that at 3 kilowatt we have 30 watt of reflected power. This is very good. Okay, I think that's it. We have shown the main features. I showed the system once again. So it's quite efficient and really easy to adapt thanks to the 4-stop tuner, because it does everything automatically. And if you cannot achieve low reflected power, you first have to adapt the sliding short. So you put the 4-stop tuner in stop position, you find minimum reflected power with sliding short, and then you turn on the 4-stop tuner and it should be better. But for us it was already going well in the middle position. Maybe Nicola just shows the last time the igniter that we use. So this is a metal tip here. It's crooked. I wonder if you can see better. And I'll try to focus here. Okay, so it's crooked a little bit here, and then it's mounted on a quartz tube, which is insulating, quite long, so you can insert it in the center. And the idea is to create the spark here in the middle, so you insert it through the quartz tube and then it ignites. Okay, that's it. We will have an automatic ignition system someday soon, so it will be even easier, and we'll keep you informed about this. Okay, thank you. Bye bye.